Welcome to Techno Sapiens.
Okay, let's dive right into this explainer. Today, we're going to unpack something you've probably witnessed, I don't know, thousands of times, but maybe never fully understood. We're exploring the split-second microscopic physics behind that sudden jump of electricity. It's a fascinating journey, and it takes us right down to the invisible forces surrounding us every single day. So, let me ask you this. Have you ever wondered why electricity just suddenly jumps through the air as a bright spark? I mean, think about it for a second. You go to plug in your laptop charger and suddenly, snap, a tiny flash of blue or white light just appears out of nowhere. Or, maybe you're watching a massive thunderstorm, seeing bolts of lightning rip across the sky. It feels like magic, right? It looks like the electricity is just deciding to leap right out of its bounds. But what exactly is that sudden flash? Why does it actually happen? Part 1. Invisible insulator. The air barrier. Well, to understand this, we first need to look at the air around us. Normally, the air actually acts as an insulator. That literally means it naturally resists the flow of electrical current. Electricity just can't easily pass through it. You can think of it as an invisible protective barrier. But when the voltage between 2 points becomes high enough, it creates an extremely strong electric field. So we've got this incredible physical tension happening here. The air is acting like a stubborn wall saying, no way, you cannot pass, while the intense electric field is actively forcing a path right through that very wall. Part 2. Chain reaction. Microscopic view. Okay, so the electric field has become absolutely incredibly strong. What happens next? We basically get a microscopic car crash. Step 1. That strong electric field grabs onto the electrons already present in the air and just accelerates them. It pushes them faster and faster. Step 2. These speeding electrons, well, they don't exactly have an empty highway. They violently collide directly with the surrounding air molecules. And step 3. The sheer impact of those collisions knocks even more electrons free from those molecules. Now suddenly, you don't just have 1 or 2 moving electrons. Those newly freed electrons, they get accelerated by the field. They crash into more molecules. They knock more electrons free. It's this rapid, accelerating chain reaction, multiplying exponentially in literally a fraction of a millisecond. Part 3. Becoming conductive. The air breaks down. Because of that wild, runaway chain reaction of colliding electrons we just talked about, the air fundamentally transforms. This is a specific scientific process called ionization. Essentially, the air temporarily stops being that stubborn insulator we mentioned earlier, and instead it turns into a conductive path. It builds a kind of invisible bridge. The barrier is officially broken down, and the current can now jump directly across the gap. And boom, that is the spark. The electricity finally makes the jump. But here's the absolute most fascinating part of all this. That bright visual flash that hits your eyes, it actually isn't just pure electricity. No, that bright flash actually comes directly from the energized, ionized air itself. The air has literally been worked up into such an intense state by those microscopic collisions that it emits a brilliant burst of light. Part 4. Real-world sparks. Everyday examples. So the crucial point to remember is that this exact chain reaction isn't just some theoretical physics concept up on a chalkboard. It happens constantly all around you. Whenever you plug a device into the wall and see that tiny pop of light, that's a miniature electric field accelerating electrons, colliding, ionizing the air, and jumping the gap. And when you look up at the sky during a storm and see a massive, terrifying bolt of lightning traveling through the atmosphere, it's the exact same process. The scale is just millions of times larger. The air acts as an insulator, the storm cloud creates a massive voltage, the electrons collide, the air ionizes, and the current jumps. I want to leave you with this fantastic summary from the experts at Techno Sapiens. When the electric field becomes strong enough, the air breaks down, and a spark is born. You see, you aren't just seeing a random flash. You are witnessing an invisible electric field conquering an invisible wall, which leaves us with a pretty fascinating question to ponder. If electricity can violently force its way through the air we breathe, what exactly happens when it tries to jump through a total vacuum in the absolute depths of space? Thanks so much for joining me on this explainer, and I'll catch you next time.